Okay, here's our lesson 2-4 arithmetic operations of functions. And you should be able to apply properties of arithmetic to functions and understand how the properties also apply to functions. So what that means is that you can take functions, add, subtract, multiply, and divide, just like we do with numbers. Really, I think the hardest part about this is just recognizing the notation. So recognizing that, for example, this notation means that it's just whatever function f is plus whatever function g is when we just add, making sure we follow rules like terms, order of operations. So you have all of this notation in your notes, and we'll get right into some examples. So example 1, we're using function f of x defined as the following and g of x defined as the following. So we have to recognize this notation as just saying to take whatever f of x is and add it to whatever g of x is. So we're going to take what we have in this, for this example, f of x is defined as negative 2x plus 4, and then g of x is defined as 5x minus 8. So now combine the like terms, we get 3x minus 4. So our answer is just a new function. Alright, well remember addition is commutative, so addition of functions is also commutative. This would just be g of x plus f of x. And you'll see you would get the same answer combining like terms. Okay, so all the properties apply. Addition, multiplication are commutative. We could use the associative property, the distributive property, and all the properties that we apply to real numbers. So in C and D, remember, subtraction is not commutative. So the answers for C and D would not give us the same function. But this means f of x minus g of x. And this would mean g of x minus f of x. I want you guys to pause the video and try C and D on your own. Alright, so for C and D, anytime we have subtraction, we need to be careful, especially when we're subtracting a quantity. Notice when I wrote f of x, I put that quantity in parentheses and g of x, because we need to remember that that's subtraction. We're subtracting all of gx. So that would turn into minus 5x minus the negative 8 turns into plus 8. Combine your like terms. Alright, look at D. Again, notice making sure we have that subtraction. It would distribute to each term in that function f of x. So we end up with 5x minus 8 plus 2x and minus 4. Combine our like terms to get 7x minus 12. Okay, the next set of examples deal with multiplication and division. So in E, this just means f of x times g of x. And remember, f of x was defined as negative 2x plus 4, and g of x was defined as 5x minus 8. So now to actually multiply these together, we need to use distribution or FOIL. We have 4 multiplications we need to perform there. So we'd end up with negative 10x squared plus 16x plus 20x minus 32. Combine our like terms and we get negative 10x squared plus 36x minus 32. Alright, notice in F, we talked before about the commutative property. Multiplication is commutative. So g of x times f of x is going to result in the same thing as f of x times g of x. And you'll see that it does. Alright, division is not commutative. just like subtraction is not commutative. So these will not result, g and h will not result in the same expression. So f of x will give us negative 2x plus 4 divided by 5x minus 8. Now there's not much we can do here to simplify this. If we had any common factors, we could take those out and simplify, but we don't. So that will be the answer. Alright, so for h, we're just going to have basically the reciprocal of what we have in g. And that's it. Okay, so example 2, it says evaluate f of x, and here we have to put the answers in expanded form. So f of x is defined as this function, so really we're just being asked in A to expand that. So we've got to remember that it means this. Which would then result in x squared plus 10x plus 25. Okay, in factored form, okay, this is factored form. It's written as a product of expressions. So in B, we're asked for f of x times g of x. So in factored form, that would just be x plus 5 squared times x plus 5 to the 4th. Now remember laws of exponents. If the bases are the same and we're multiplying, we can just add the exponents. So this can simplify into x plus 5 to the 6th. So this is still in factored form because we should see that this is the factor x plus 5 written out 6 times. Alright, so if we're looking at f divided by g, so f is x plus 5 squared, and g is x plus 5 to the 4th. Again, laws of exponents. These are considered the same base. So we can subtract or take the difference in the exponents. We have more of these in the bottom, so this would simplify into 1 over the quantity x plus 5 squared. So just like with numbers, when we're writing ratios, we should simplify, reduce. So that's really all we're doing, and it's still in factored form because we haven't actually done the multiplication here in the denominator. Alright, so the reciprocal, oh no, this isn't the reciprocal, I'm sorry, it's the same. It's f of x divided by g of x, which is what we still have in C, but now it's in expanded form, which means we want to actually take that denominator and multiply it out. So it would mean this. We want to actually do this multiplication, which would result in x squared plus 10x plus 25. Alright, I want you guys to pause and do E and F and then check your work. Okay, here are the answers for E and F. Function G divided by function F. Again, still the same bases. So we subtract the exponents. We have more on top, so we end up with the quantity x plus 5 squared. That's factored form. Expanded form would be the quantity x squared plus 10x plus 25. Alright, last example, where we're using the graph to find the function values. F of 3 means we're looking for input of 3. What is the output? So if the input is 3, should be about there. The output looks to be about 5. So we can add these function values. So we just have to find f of 18, which would be right here. So that would be 16 plus f of 3, which was 5. So the value here would be 21. look at the rest of this table, I've shown how I've gotten the values for each function value, written those down, and then actually just performed the arithmetic on those function values to get the answers that I have circled. Alright, that's it.